Hey everyone, so far when we've been working with code and numbers, it's either been us, programmers, giving those numbers values to write in the code or letting the user type them in. But we've never really let the computer do it on its own. What I'm getting at is it's time to teach you how to generate random numbers, because random numbers pop up everywhere in tons of situations. Here are a few that came to my mind first. Password generation. Programs use random numbers to pick characters from a set of letters, digits, and symbols to create strong passwords. Next is games, like rolling dice or random loot drops. In games, random numbers decide battle outcomes, what items drop, enemy movements, and more. Next is random selection, randomizer. An app that picks a random winner's name from a list of participants. Encryption and security. They're used to generate keys and initialization vectors in cryptography. And the last one is simulations and modeling, like weather simulation. Random numbers help mimic unpredictable events. And honestly, this list could go on forever, so it's super important to learn how to use this in your coding projects. There are two ways to work with generating random numbers. The first way came from the C language and carried over into C++. That's what we're gonna focus on in this lesson. The second way showed up later in C++, and it's way more flexible, powerful, complex, and efficient. But to really get that one, you need to know a bunch of other C++ stuff first. For most cases, when you're learning C++, the first way is totally enough. The first way uses three functions. The first one is called rand, the second is srand, and the third is time. Together, these let you generate random numbers. Let's start with the rand function. It lives inside the std namespace, so every time you want to call it, you have to write std first. The function itself is already compiled into the C++ library, so we can't peek inside to see how it works, but we can look at its prototype. To do that, just type std-rand, right-click it, and choose Go to Declaration. Or you can select the function and press Ctrl plus F12. From now on, that's how I'll check function prototypes. This should take you to the file stdlib.h. We'll talk more about that file later, but for now, just know that the functions declaration is in there. You can include this file directly in your code with the command include stdlib.h, but you don't have to because it's already included if you use include iostream. Looking at the prototype might freak you out a bit because there is a lot of stuff you don't know yet, but let's find what we do know. First, there's the return type. It means the function returns a random number as an int. Let's pause here for a sec and talk about number generation in general. We'll only use this function to generate numbers, so the range of random numbers will always fit inside the int type. Next, we see the function's name, rand, which is short for random. Then there's the parameter list, which just says void. Back in language C, you had to write void inside the parentheses to say the function takes no arguments. In C++, you can just leave the parentheses empty, but for compatibility with C, they kept the void there. Alright, let's try calling the function. In this code, I'm calling it 5 times. If you run the program, you'll see it gives you 5 random numbers. If you want to call it 100 times, you get 100 random numbers. Just remember, sometimes numbers repeat, that's part of randomness, and that's it. Now you can work with random numbers. You can assign random values to variables or print them right to the screen. But here's the thing, when you start using this function, you'll probably notice one problem right away. Every time you run your program, it gives you the same random numbers. Like the first number is always 42, and then the others follow the same pattern. Why does that happen? Let's think about how you come up with a random number. Our brains work in crazy complex ways, and when we pick a number, it's based on all sorts of conscious or unconscious connections, memories, past experiences, or even what's around us at that moment. But a computer doesn't have any of that, so the only thing it can start from is an initial number for randomness. Imagine you wrote a big formula that uses a starting number, say 0, and every time you call it, it gives you a new random number. The first time it starts from 0, but after it generates a number, say 42, it changes that starting number, and every time you call it after that, it uses the new starting number to generate the next number. That's exactly how this function works. There's a starting number called a seed. I don't know what it's set to by default, but every time the function runs, it uses the seed to calculate a random number. Then, to avoid giving you the same number again, it changes the seed to a new value based on that calculation. Because of this, each call gives you a different number. The problem is, the seed itself doesn't change between program runs. Every time you start the program, the seed is reset to the same value, to the sequence of random numbers repeats exactly the same way every time. To fix this, we need to learn how to change the seed. That's what the srand function is for. The name stands for set random or seed of random. It's in the same file as rand. If we look at its prototype, we see it doesn't return anything but takes a number as input. That number is the new seed, the starting point for randomness. Just keep in mind, it needs to be a positive number. So, whenever you work with random numbers, you should call srand at least once and pass it a number before calling rand. Then each time you run your program, you'll get a different random numbers. And with each different seed value, you'll get a different sequence of random numbers. But honestly, we haven't really solved the problem yet. We just learned how to set the seed. The thing is, the number you pass to that function is still a fixed number that doesn't change when you run the program again. That means you'll keep getting the same sequences of random numbers again and again. Sure, you could let the user type in the seed value themselves and pass it to the function, but the user will quickly figure out that if they type the same number, they'll get the same random numbers every time. So what we need is a better way. We need to pass a number to srand that does change every time the program runs. What could that be? For example, time. In C++, there is a header file called time.h that has tools for working with time. Inside, there's a function called stdtime, which gets the current calendar time. When you call it, it returns the current time as the number of seconds since the epoch, usually January 1st, 1970. Let's check out its prototype. You'll see it's in the time.h file. This was originally from C. Instead of just a prototype, here you might see its definition calling some other internal function. You won't find the full definition, only the prototype. It's common that if a function starts with 1 or 2 underscores, it's a system function and regular programmers don't call it directly. So we'll just focus on time. It returns a type called time t. If you hover over it, you'll see it's really long under the hood. Time t is just a type alias. In another lesson, I'll teach you how to make those aliases. For now, just think of it as a convenient name for a type. The number this function returns is the number of seconds passed since the epoch. Every time you call it, you get that number. If you call it multiple times within the same second, expect it to return the same value each time. But usually you don't run programs multiple times within less than a second, so this value is good enough to use as a random seed. The function takes one parameter, a pointer. We haven't learned pointers yet, so just ignore it for now, and always call the function with 0 as the argument. When we get to pointers, I'll explain what's going on there. Back to our code. For now, call the function like this. Pass 0 as a placeholder, just so it compiles, and it will return the current time in seconds. Run your program several times and notice how this value changes, or rather increases every second. Now, by combining all three functions, we can properly work with random numbers. At the very start of your main function, you call srand and inside its parentheses call time. This way, the return value of time goes straight into srand. That means every time you run your program, you get a new seed. After that, you can call rand as many times as you want. Remember, call srand and time once at the beginning, then rand however many times you need. Run your program and now see if the numbers change. Now, you can write your own wrapper functions if you don't like the original names. For example, I wrote three functions: get current calendar time, set random seed, and random int. They're simple, but unlike the library functions, they have clear, understandable names. I rewrote the code and now it looks much cleaner. But we can do even better. You can make get calendar time the default argument for set random seed. That way, you don't have to call it explicitly, and you can even take it further so that set random seed doesn't need to be called at all inside main. But we'll talk about that in future lessons. We'll learn how to work with random numbers, but there's a catch. The function std_rand only returns numbers between 0 and 32,767. If you check the declaration of this function, you'll see a macro called randmax, right next to rand and srand. What are macros? We'll cover that in a separate lesson, but for now, just think of it like a constant with this value. That value is written in hexadecimal. We'll explain hex later too, but if you convert it, it's 32,767 in decimal. Why that number? Well, rand was created way back in C, around 1989. Back then, an int was 16 bits or 2 bytes, and the max value for a 16-bit signed int is 32,767. Since this was carried over into C++, the value stuck. Now, what if you want a smaller range, like from 0 to 100 or 10 to 20 or even from minus 23 to 45. In those cases, you have to do some math with the number rand returns. Let's start simple. Remember the modulo operator. If you want a random number from 0 up to x, not including x, just take the rand value modulo x. For example, if x is 100, imagine picking any number and dividing it by 100 and taking the remainder. If your number is less than 100, you get the number itself. If it's exactly 100, you get 0. If it's more than 100, you get the remainder after division, which is always less than 100. So this is how you get a random number from 0 to x minus 1. If you want to include x, just add 1 to it. In my example, I generate 10 random numbers between 0 and 100. Let's run it and see. Now, for a trickier range. What if you want a random number between y and x, like from minus 10 to 10? You can use this formula: std_rand modulo, open parentheses, x minus y, close parentheses, plus y. Let me break it down. First, you get a random number from rand. Then you cut it down by modulo division. But by what number? From minus 10 to 10, subtract 10 minus minus 10 equals 20. So first, you get a number from 0 to 19. Remember, modulo excludes the top number. But we want numbers from minus 10 to 10, so we add y, which is minus 10, to shift the range. If you want to include the upper bound, just add 1 inside the parentheses. Let's run this and watch the results. To avoid writing this formula all the time, you can just write your own function that returns a random number in any range you want, like in this example. Let's run the program again and you'll see that the last number in the range can also appear. And finally, let's think about how to get a floating point number using a function that only returns integers. Imagine you want a float between y and x. Here's the formula you'd use. std_rand, but first open parentheses, std_rand, divide double rand max, close parentheses, times by, open parentheses, x minus y, close parentheses, plus y. Let's break that down. You'll notice I didn't change much. I just divided the random number by rand max. Remember, rand max is that macro we talked about, which is the max value rand can return. Why cast it to double? Because both rand and rand max are integers, and if you just divide one int by another, you'll get an int result, meaning no decimals, just 0 or whole numbers. By casting rand max to double, the division becomes floating point and you get a decimal number. You could also cast std_rand to double if you want, either way works. So what kind of number do we get after dividing a floating point number between 0 and 1? Then you multiply that by your range, x minus y, to scale it up, and finally add y to shift it to your desired range. Let's try getting 10 floating point numbers between 1 and 5. Let's see what we get. Remember, we're using a macro here, and we'll cover macros in detail later. For now, just think of it as a constant value plugged into this expression. Also, x and y can be floating point numbers too. For example, with this formula, you could get a random float between 2.45 and 5.67. I even wrote a separate function for this that returns a random float. Feel free to use it if you want. Alright, now let's talk about why using those old school functions to get random numbers like rand, srand, and time is kinda outdated. Using them in modern C++ isn't the best idea because, first, they don't play well with multi-threading. Because std_rand is a global function and uses global state, so it's not thread safe. That means in multi-threaded programs, you can't really trust the randomness to be correct or independent across threads. Don't worry, we'll dive into multi-threading way later. Second is, the randomness quality isn't great. std_rand uses a pretty simple algorithm, usually something called a linear congruential generator. It's predictable and has low entropy. Entropy is just a fancy way of saying how random or unpredictable something really is. So this makes std_rand not great for crypto, simulations, or any serious random stuff. Third, the range is too small. std_rand only gives you numbers from 0 up to 32,767. That's just not enough for many real-world cases where you need higher precision or bigger ranges. And fourth is, you don't have good control over the generator. There's no way to create independent random generators or control the seed locally. You only have the global std_srand seed function, which affects all calls to std_rand in your whole program. By the way, a generator is just an object or function that creates a sequence of values on demand. So yeah, std_rand and std_srand are old, unreliable, and limited. They still work, but in modern C++, it's way better to use the random header. It's more flexible, powerful, and safer. I'll do a separate lesson on that later, because there's a ton of new stuff to learn first. But honestly, for about 99% of the tasks you'll have to while learning, those three functions are enough for now. And that's the end of this lesson. Thank you for watching. If you enjoyed the video, you can support my work by giving it a like, leaving a comment, subscribing to the channel, becoming a channel member to get access to practice lessons, or donating via the link in the description. All of that helps the channel grow and keeps me motivated to make more lessons for you. Goodbye.